We're looking at the grade 10 Exemplar 2012 paper, and it's a question on electrostatics. Two identical metal spheres A and B on an insulated surface carry charges of negative 2.8 times 10 to the minus 6 coulombs and 4.5 times 10 to the minus 6 coulombs respectively. The spheres are brought into contact with each other. It is observed that the spheres move apart after contact. Briefly explain this observation. Now we know that because these two charges are unlike, we can see that one of them, A is negative and B is positive. They are unlike, and we know that unlike charges attract, right? So they attract and they move closer to each other until they are brought into contact. And during contact, there is a transfer of electrons until both spheres have equal charge. And now that they have equal charge, they would be like charges and repel and move apart. So let's just write this down. So the first thing we said is they were unlike charges, so they attract, and then they are brought into contact. So during contact, electrons are transferred until both spheres have equal charge. They now have like charges, so they repel and move apart. Okay, so that would earn you your 3 marks. A mark for talking about unlike charges attract. During contact, electrons are transferred until both spheres have equal charge, and then the like charges repel, so the spheres move apart. They now ask us to calculate the new charge on each sphere after they have moved apart. For us to find the new charge, we would take the charge on the first sphere plus the charge on the second sphere and divide that by 2 so that there is an equal distribution. So charge A was negative 2,8 times 10 to the minus 9 plus 4.5 times 10 to the minus 9 all over 2. Putting that into our calculator, we would get 8,5 times 10 to the minus 10 coulombs. And that would be the new charge on each sphere after they move apart. 11.3, calculate the number of electrons transferred from one sphere to the other during contact. So to find the number of electrons transferred, we would use the equation change in Q over QE. And change in Q means the Q final minus Q initial all over the electron charge. So to do this, you could either use sphere A or you could use sphere B, and you would get the same answer because one of the spheres is losing electrons and one sphere is gaining electrons, and they would each lose or gain the same number of electrons. So if I'm using A, then I would say the final charge of A we calculated, it was 8,5 times 10 to the minus 10. The negative here is the negative of the equation. I'm now going to substitute the initial charge of A, which if we go up to the question, we can see it was negative 2,8 times 10 to the minus 9. And I would divide this by QE, which is the elementary charge on an electron, 1.6 times 10 to the negative 19. And we get that from the data sheet. Putting that into our calculator, we get 2,28 times 10 to the 10 electrons were transferred. Now just to show you that if I used sphere B, I would get the same answer. If I want the number of electrons transferred, then I would take Q final minus Q initial all over QE, and this time we are using B. So we said that B's final charge was also 8,5 times 10 to the minus 10, and B's initial charge, if we go back to the question, It is 4.5 times 10 to the minus 9, all over 1.6 times 10 to the negative 19. And when we put that into our calculator, we would end up with the same answer, 2,28 times 10 to the 10. And actually you would get a negative answer here, negative 2,28, and that's actually fine. So you could use either A to substitute into this equation, or you could use B, as long as you substitute correctly. And if we get a positive or negative answer here, it just means that one of them lost electrons and one of them gained electrons. Another popular question which they like to ask is, in which direction are electrons transferred, from A to B or from B to A? And how we answer this is, electrons are always transferred from the more negative sphere. From the more negative sphere towards the more positive sphere. So if we go back to the question, we can see that A was more negative, negative 2.8, and B was positive. So that means that electrons are transferred from A towards B. I hope you found this video useful. Like if you did, subscribe so that you don't miss future videos, and share this video with your friends so that more people can benefit from these lessons.